Just competing with the music there. Good morning again here in Santa Clara, California. Day 2, Cloud Expo. This is for the benefit of anyone who's now just joining us for the Day 2 keynote out there on the World Wide Web. Day 2, Cloud Expo, Santa Clara, California. Pete Malcolm probably needs no introduction by now. If you've been following the Abiquo story through the last few Cloud Expos, this is in itself a great testimony to the power of the cloud, to how a vibrant company with bright management, smart engineers can create a really interesting story. Let's give it up, please, because I don't want to steal his time, for Pete Malcolm, CEO of Abiquo, and let's hear about this tightrope, Pete. I just didn't hear thunderous applause.
Good morning. So today I want to talk about balancing the cloud to ensure success. We believe that there's a lot of instances where people are not balancing the cloud and are focusing on the needs of one particular stakeholder or other, and if you do that, the whole thing doesn't work. And let me explain how and why. Just as an aside here, we're going to be following this up with another session tomorrow where you guys can get to give your feedback to us. Follow along here. If you've got big things to say, stick them on the blog, petemalcolm.com. You've got little things to say, stick them on Twitter, and we'll collate all those together so when we get to a session tomorrow, we can get your feedback, because that's what we're really interested in. So let's start with the stakeholders, and we're talking here about what we call enterprise cloud. That means essentially servicing the needs of the enterprise, and we're talking about private cloud, we're talking about MSPs providing services to those enterprises. So private cloud, hybrid cloud, public cloud, if you think about it from an MSP's perspective. That's what we're talking about. And really, if we took in very simple terms about the stakeholders here, they really fall into 3 groups. The first is the guys who are providing the physical infrastructure that creates your cloud. And that could be coming from data centers that you own around the world. It could be coming from conceivably a public cloud provider, but it's the physical infrastructure, the compute, the storage, the networking, that those IT operations guys make available, if you like, into the cloud. The second set of stakeholders are the application and the development teams, the people who are actually consuming the cloud, the guys that are running the application side of the house. They're the consumers, and they are, in a cloud sense, they are consuming virtual resources. You stick physical resources in and you get virtual resources out. And then the third group of people are the compliance and CFO and those type of guys. And they really care how those two map together, how the operation side, the physical resources, maps to the virtual resources. And we'll give you some examples of how that is. I mean, clearly they're talking about making sure it happens in the right way, that it's secure, and above all, that we're actually saving money. Remember, that's what the whole premise of this thing is, that we're actually going to save you some money. Comments that we had on the blog already, we started this a week or so ago, and you can see here, this is one comment we've had. Our company started a private cloud initiative, but what IT delivered was so constrained nobody would use it. Classic example of trying to bias your cloud in one direction or another for the needs of one particular stakeholder, completely failing the other stakeholders, and so the whole thing doesn't work. So let's talk about what the drivers for the applications and development teams are. They, above all else, want self-service. They want to be able to provision what they need to provision when they need to provision it. They want that to be as flexible as possible. They want to be agile. They don't want to have the delays associated with the old world, the pre-cloud world, where they had to make a request to the IT guys and it took however long it took. In a big enterprise, that can be weeks, even longer sometimes, before you actually get your thing provisioned. And that has real knock-on effects, as we'll see a bit later on. These guys are concerned about IT operations intervention. In other words, they don't want it. They want to be able to do it when they need to do it. They're concerned about being restricted in what they can do. And they're also, sort of kind of the opposite of that, they're also concerned about complexity. The little diagram you've got there, you may recognize it, that's the Amazon Web Services management panel. And Amazon Web Services is an example of something that is incredibly powerful. if you know what you're doing, as we'll see. It's also very difficult to use if you don't. And it's very easy to make things to get things wrong, as you'll see shortly. So complexity, you can have too much of it, as you'll see. Here's a view from an IT operations guy, completely the opposite. AWS is like juggling sharp knives. Unless you really know what you're doing, sooner or later you're going to get badly cut. So AWS is so powerful and you can do so much with it, it's easy to get into trouble. And this is what scares IT operations guys. And here he goes on to say, the risks are not from the occasional outage, but from users who don't know how to properly secure it. That's the concern of IT operations. So for IT operations, the drivers are, yeah, sure, they want to reduce their workload. They're overworked and underpaid, as I'm sure they'd tell you. They want to reduce their workload and be able to focus more on satisfaction and delivering their services to whatever SLAs they're required to. They are certainly concerned about visibility. They need to see what's going on. The problem one of the problems that IT operations has with an Amazon-like public cloud service is they have no visibility or control into it, and that scares them. They need security. They need to make sure that what you're doing is not going to expose anyone else or the organization in general to, for example, viruses, malware, all that kind of stuff. That's a huge concern of IT operations. How do they make sure that works if they're empowering you fully to do what it is you need? And lastly, they need integration. They need integration with their existing services, the directory services, the corporate stuff. How are we going to make that work in a cloud environment to make sure all that hangs together? And if we talk about the needs of compliance and the CIO, and I've kind of stuck those guys together in a bucket, although what they're actually seeking is slightly different. They're conceptually the same in that they're concerned about how those two sides, the physical and virtual, map together. So cloud doesn't save you money when you allow consumption to get out of hand. So clearly, if you allow people to be too empowered and be able to do too much, they can consume what they want. Now, of course, that's exactly what Amazon wants you to do. And I don't think I'm knocking Amazon here. This is a great service. But from an enterprise point of view, it's totally uncontrolled. The only thing that controls what you do as an Amazon is when your credit card runs out. Otherwise, you have no ability. And it's almost impossible to find out ahead of time what something's going to cost you because the pricing model is so complex that you really have no clue what comes in. Most compliance situations assign all of the responsibility to the user. This is Forrester talking here. All of the responsibility to the user, and that's an impossible situation to manage in the cloud. You can't give all of the responsibility to the user. You've got to do something about that. So again, compliance and CFO, what are their drivers? Absolute number one driver for the CFO, of course, is to save money. And people, this kind of gets swept under the carpet sometimes, but it absolutely has to be the case. The cloud is not worth doing unless it saves you money. That's the whole point. They also are interested in auditability. Compliance and the CFO want full auditability. Where was all that stuff? When? Who else was on the same box? All of that stuff that people have big concerns about in the compliance world. And their concerns are data loss, kind of the opposite of security. They're worried about stuff going out of the corporate environment and somehow getting someplace it shouldn't be. If you take it to Amazon and you accidentally expose it on Amazon, that data can be lost, that corporate data. That's what scares them to death. Clearly, they're concerned about compliance issues, from sort of the classic Wall Street example of research must not share physical hardware with investment banking to a myriad of others, some examples of which I'll talk about a bit later on. And they're interested in governance, making sure that they can comply with all of the various governance regulations that only get bigger, not smaller. And public cloud makes that hard to do. So we've got to look at how that can happen. So essentially on that last piece, they want to sleep at night is the message there. We believe that the cloud solutions today largely fall into two categories. Those that are focused on the needs of the application and development teams and are largely ignoring what the IT operations guys want, and those that are focusing on the needs of IT operations and ignoring the needs of everybody else. Now, I'm talking in black and white here, and of course it's a grayer situation than that. But what you need is a solution that is balanced across the needs of all three. Because as I've said, if it don't have that, it won't work, and I'll demonstrate to you why that is. So let's talk about some specific needs of those individual stakeholders. And I'm just going to focus on a few here. There are many more, but these are some key ones. So for the application and development teams, the ability to have complete provisioning capability is key. It's no good being able to provision some things, like the compute side of it. You know, every vendor will show you how they can launch virtual machines for you. That's fine. But unless you can also fully self-service the storage and the networking, it isn't self-service. If you have to ask an IT guy to do any part of this, it's not self-service. And there's real critical reasons for that we'll get to. So first of all, let's consider, I'll ignore the compute side, because as I said, most people get that right. Let's consider first of all the storage side. And remember that there are various different types of storage, and different types of storage requirements for a sort of test dev environment and an enterprise environment, quite different. So here we have our hypervisor host machine, physical server, that's running various virtual machines in it. In the enterprise world and in the MSP world, those machines typically do not have local disk attached to them. That's far too hard to manage. They have one of two types of key storage. And I'm not talking about you know, whether it's connected via iSCSI or fiber channel or any of that sort of stuff. I'm talking about fundamentally they have two types of storage. The first is usually known as an NFS data store, sometimes called the hypervisor data store. And this is where you have a storage device that has a block volume, a raw block volume exposed, and the hypervisor manages the use of that storage. And essentially, it puts files on that block volume, and each of those files represents a logical disk on one of the machines. And that's managed by the hypervisor technology. Now, this has some disadvantages to it. First of all, you've got a performance overhead, perhaps not a huge one, because hypervisor vendors have worked hard to try and eliminate that. But clearly, you've got a double stage there. You're putting something, you know, you've got two file systems, if you like, stacked one on top of the other. So that obviously is going to have some performance impact. You have a scalability issue because the number of connections that you can have to a single NFS data store is usually limited, and your hypervisor vendor will tell you there's a limit to how many virtual machines or how many physical hosts you should connect to that hypervisor data store. Often it's done in a clustering model, and you only have one cluster talking to one NFS data store. So there's a scalability issue there. Remember, clusters are typically limited to a maximum of 32 machines, often less. The big issue here is that you're limited to the storage management functionality that the hypervisor gives you, because it's isolating you from the storage device. If I, for example, were to try and do an operation on that storage device by, for instance, deciding to back up that block volume, I'd have to back up the whole thing, and I'd be backing up all of the files within it. Trying to do something selectively is much more difficult. You have to rely on the hypervisor to do it for you. And you've got limited portability. You can't suddenly, you know, if you've got thousands of machines, it is very difficult to move a storage volume amongst thousands of machines. You can do it within the machines within the cluster, the 32 within the cluster, but moving it outside that is much harder. The alternative to hypervisor storage, which is typically used in test dev environments, effective there where some of those issues aren't so apparent, the alternative to that is using raw block storage. And this is what the storage vendors like. This is what they can, where they can provide you with real advantages, where you can get all of the advantages of performance and scalability. All of the sort of tools that those devices can provide you, like the ability to take instant snapshots, they're all done at a volume level. So for an individual volume, you can't, you know, on the NFS data source side, you can't do it without snapshotting them all. Okay? Instant backups, cloning, all those sorts of benefits that the storage vendors have provided in their products, you can get benefit from if you're using their raw storage directly. And it's portable across different hypervisors. You can pick up that volume and you can stick it somewhere else, even on a completely different hypervisor technology, attach it to that. But the way to really service storage, if you're talking about a cloud environment, is to do it in tiers, because you want to isolate your users from physical storage devices. You don't want them to know anything about physical storage devices. The IT operations guys want to be able to add and expand physical storage, bring it in from other physical sites whenever they want. You want to have your users deal in tiers of storage where you determine which physical devices make up particular tiers. And let's give you some examples of that. So in this example, we've got 3 tiers of storage, and each of those tiers might have different characteristics to it. So at the top end, tier 1, we might have storage that's automatically replicated in 2 data centers for resilience. We might have it, particularly high performance, all those sorts of things. Whereas down to, tier 3 or tier 4 might be much cheaper storage, much lower in performance, and you choose what price performance, replication functionality you want, and you pay for it accordingly. This is a much more effective model and takes all that other stuff completely out of the picture. So let's see that practically in action here. This is the Abiquo solution, just going to demonstrate it for you, and I'm not particularly trying to promote Abiquo, I'm trying to show you what it means. So we've decided here that we want to create a volume, we give it a name, we give it a size, tiny sizes here because it's a demo system, and we pick what tier of storage we want. So you're seeing the consumer experience here, the cloud consumer experience. You create it, and under the covers, the solution is going and talking to whichever physical storage device it's actually selected for you, going and creating that volume, and then bringing it back and putting it here, ready for you to go and attach it to whatever virtual machines you want to. You didn't have to ask an IT guy to do that. Very few solutions allow that. Let's talk about applications for a moment. People tend to think about applications in very simple terms. I want a web server. That's how lots of vendors will talk to you. I can self-service a web server for you. But enterprise life isn't like that. We don't have a single virtual machine that we just expose to the internet and hey presto, there's your web server. There's much more to it than that. And even this diagram is quite simplistic because I haven't put any kind of resilience in here. So you need a firewall at the front to keep the bad stuff out, just decide what you're going to allow through. You need a load balancer if you've got a heavy-duty application, so you can balance it across multiple web servers. You need databases on the back end. That's what a real enterprise application starts to look like. And in reality, it's more complex than that. It's not a virtual machine running a web server just exposed to the internet. It's much more than that. This is what you don't want. If you think about in network connectivity terms now, what you don't want is one internal network and just one firewall allowing you to break through that. So once I'm through the firewall, I can get to any of those things, directly to any of those components, and directly to other components that might not even belong to me, might belong to completely different teams. That's not what you want. What you want is this. Take that same model we had earlier in the same kind of topology and have the ability to yourself self-service virtual networks so you can isolate all that stuff yourself. And you want to be able to do that, again, without asking an IT guy. If you have to ask an IT guy, it ain't self-service. And as I keep banging on, we'll come up as to why complete self-service is really important in a moment. So let's go and look at the experience. Again, we use Abiquo as an example of how you actually go and create your own network. We're looking at the network tab here for the consumer. You've got a default network there, and what we're going to do is to go and create a private network. So we give it a name. We can choose whatever numbering system we want for it. We're going to pick a 10. I think it's going to be a 10.4 numbering system. We're going to choose how many addresses we actually want to create. So we're going to create a /29 network, which is going to give us 6. Create it. And all the mapping in the background to physical switches and all that kind of stuff is completely done for you. There I've created my network. There's my 6 addresses for me. And now I'll show you how you can just as simply go and, having created those addresses and that separate VLAN, here is my application, and that's my virtual machine within my application canvas there. I'm going to go and open that, look at its network connections, and simply add in that network. So pick from the private network, pick one of my 6 available IP addresses. Number 1 will be the gateway, but pick the second one. Simple as that. We've now got 2 virtual network interfaces on that virtual machine, one connected to each of those 2 networks. Now we could, of course, delete the default one if we want to. And so you can see there how easy it is to go and take your appliance, your application, and create those VLANs any way you want to. Again, you did not need to involve an IT guy to do that. Critically important. Now let's switch from thinking about it from the perspective of the consumer, the application development teams. Let's focus on IT operations now. What does IT operations want? Well, the last thing it wants you to be able to do is to expose your applications, your virtual machines, and risk anyone else being exposed. And the way that these are normally organized, certainly in our application, the way they're organized, is your whole cloud is divided up into, your consumers are divided up into tenants. Each tenant needs to be isolated from the others. And more than that, we also find that most companies want to be able to have subtenants. Certainly if you're an MSP, you want to be able to do that. So the tenants at the top level would be your top level customers, each of which would be a different company. And those companies might want to subsell or subdivide the resources into their own departments, for example. Lots of instances we have customers that do that. So what I need is to be able to isolate, in this case, each of those subtenants automatically on its own VLAN. And again, with the Abiquo solution, that happens totally automatically. Whenever you create a new subtenant, it is automatically isolated. It's that default network we saw just now. You can't not have it. So it is no way you can get between those subtenants. Okay? IT operations needs to enforce resource limits. It needs to make sure you can't consume more resources than are available, or more resources than have been budgeted to you, if you like. The way we do that, again, we've got the same model here, and we effectively create a sandbox. Now, we talked about a sandbox having the VLAN boundary around it. Well, if you think about the dimensions of the sandbox, how big it is, what you can do in there, think about the dimensions of the sandbox relating to the resources you're allowed to consume. So we've only got two here because we can only draw in 2 dimensions, but we've effectively got 20 virtual CPUs we can use. We can use up to 10 gigabytes of virtual RAM. And we know, as IT operations, we know that that tenant will not be able to consume more than that. But the tenants control the subtenants. So having given a set of resources to a tenant, he can divide it up amongst the subtenants however he wants. So if you're an MSP, you have a customer, he can then sell those resources, divide them up amongst his own. But you know the size of the sandbox you've created, and you know collectively the size of all the sandboxes you've created. And you can ensure that those don't exceed the physical infrastructure that you've got. How does that look again, back to the real world? Here we have the ability to select your resource limits. Each of those at the top level there, so my button works, just about. There we can set, this is the RAM, the virtual CPU, the local storage, external storage, repository storage, number of VLANs, number of public IPs. Decide all of those, how much that enterprise or that subtenant is going to be allowed to use. And you can also set soft limits. The orange slider bars underneath them say at what level you're going to start warning those users that they're running out of resources when they've consumed them. Here's how you can look at overall collectively what the sandboxes are doing. This is looking at the cloud enterprise as a whole. I could, so everything in the cloud, I could go down and drill into any one of the physical data centers we've got there. So these are the physical data centers that make up that totality, but we're looking at the whole thing here. And you can see here the yellow bars tell you how much resources you've allocated. The green bars tell you how much you've actually got, and the red bars tell you what's actually in use. So you can see there are some potential danger situations. Here, for example, we've actually sold more storage than we've actually got. Fortunately, nobody's using it yet. When the red bar gets to the top of the green bar, that's when you're in trouble. Okay? But in this instance, we've actually allowed the system to oversell. You can decide whether you want to allow it to oversell or not. That's up to you. But easily reported to you, know instantly what's going on. Next thing is role-based empowerment. This is something we've just introduced with Abiquo in the last 9 months. Very important to be able to decide what your users can do and what they can't. Now, I talked earlier about and showed you examples about almost extreme amounts of empowerment to users. That may not be appropriate to everyone. What you need to do is, first of all, provide a rich set of privileges that you can select from. Options, if you like, as to what you want users to be able to do and not do. You want to be able to define individual roles for each class of user, and you don't just want IT operations to be able to do that. You want to be able to allow tenants to do that for their subtenants. Obviously, you're not going to allow them to have more privileges than the tenant itself has, but you need people to be able to define them for their own subtenants, because I know how my company works, I don't know how your company works. Okay, so again, being able to do it yourself. And you need to match the user's level of sophistication. It's not just making buttons become inactive. It's about simplifying the user experience. If you need your users to be less empowered, have less choice, don't present a load of choices that don't work. Reduce it to what they actually have, and increase the amount of information you give them. Less sophisticated users need more information about what's going on. You need to retain the self-service capability, however. And it's very important not to introduce workflow barriers unless you really, really have to. So, because as soon as you introduce workflow barriers, the self-service becomes lesser. You've got some part in the way that's stopping that happening, some kind of approval process or something like that. You want to eliminate that if you possibly can. So, I know you can't read this, but here's an example, for instance, in the Abiquo solution. There's the page that allows you to define your own roles, and you can see there's a whole myriad of things you can turn on and turn off, depending on what you want your users to do. And when you turn it off, it disappears. So the user just doesn't see it at all. So you're not confusing them with something, and they say, why can't I do that? It's just not there. Let's show you the absolute opposite of the full empowerment we showed you earlier. Here you're still empowered. This is an ability to select individual applications from a very short list. So each of these is an appliance, and you simply select the one you want, click the button that says provision it for me, and within 15 seconds you've got back an email that says, okay, I've provisioned that application you wanted. So still self-service, but much less ability to mess with configurations, do things you don't want to do. It's all been pre-done for you. And with role-based empowerment, you can have the best of both worlds, because you define roles that allow you to do as much or as little as you want. So you can give sophisticated users the complex thing we saw earlier, where you can define whatever you want. There's right up to the full Amazon experience, if you like, right back to this much more simple method of deployment for those people who have less sophisticated users. And you can have them both at the same time and anywhere in between all at the same time. It extends to actually provisioning individual enterprises. Here we're going to allow someone to create their own enterprise within agreed limits, and they're going to actually request how much of each of those virtual resources they want. And you can see as they fiddle with the sliders, the numbers go up and down, and you can see exactly how much you're spending, and you can see the totality of the cost there. So you're informing the users about what this thing is going to cost them before they actually choose it. You can see a great example of this if you come to the Abiquo booth. One of our own customers, CarryNet, uses a system very similar to this to allow, they're a hosting provider, they allow their customers to go right off the web page on their site and go and buy their own virtual enterprise, and you can be using it in under a minute. Built using exactly this kind of portal. Let's talk about compliance and the CFO and focus on their needs. And the key to that was what we call business policy, again, which determines how the physical world maps to the virtual world, okay, well, all the other way around. The important thing here is, in deciding where those virtual resources map, it's decided ahead of time. Not where they go, but what the decision process is as to where they go. It's not something that's thought about after the fact. The policy is defined ahead of time. And it's automatically enforced each and every time a virtual resource is provisioned. You can't not do it. It happens automatically. So whenever you go to provision an application or a virtual machine, policy is applied, it looks at the rules, it says, given who you are, given what it is you're trying to provision and various other business constraints, this is the candidate machines that it could go on. And let's look at some examples of that. So here, this first example is restriction. You probably can't read it, I'll read it for you. This is the ability to say that Group A, Tenant A, cannot share a physical resource with Tenant B. And the classic example of that is the Wall Street investment banking and research. I both want you to use this cloud. I want both of you to I don't want to have to create completely separate silos of hardware for you, because that's very inefficient, but I want to make sure that those two groups never share a physical storage device or a physical server or a physical rack of servers or even a complete data center if you want to go that far. But you don't have to split everything into two complete separate systems and have different users using different things to make that work. Simple policy rule. Next example here, the ability to set permissions as to which data centers you can use. So we've got physical data centers potentially located all around the world here. And in this example, we're looking at our US investment banking enterprise, and we're saying it is only allowed to use physical data centers in the US. So perhaps it's not allowed to use them at hosting providers, for example. So this is our, you are the team that runs our trading applications. You can run in any data center that we own that's located in the US, but nowhere else. You're the team that runs our public web servers. Don't care where you put them. Don't need a rule for that. Another example here about reserving hardware for a particular purpose. In many instances, you buy particular devices for a particular task. I bought those Cisco UCS machines to be used for my trading application. I want the whole thing managed from within the same cloud, but I want to set a business policy rule that says those physical machines are reserved only for those guys to use. And now let's get on to some different ones. This time we're going to consider, instead of the compliance side of the thing, we're going to consider the CFO and what the CFO wants, which is to run the thing as efficiently as possible. Now, right here, we're doing the opposite of that. We're saying here that for a particular application, performance is the key. And I therefore want you to optimize the use of physical hardware so that you spread the load across all of the physical devices I've got. Very inefficient from many perspectives, but fabulous from a performance perspective. And you might want to do that for a subset of your applications. My trading application, that's mission critical to me. That's got to go as fast as it possibly can. So that's one way of setting a load balancing policy. Here's the opposite of that, a progressive policy where we are filling up one physical device before we even turn the next device on. And here you can see that the devices at the top there, we haven't used at all. And we'll backfill, as virtual machines in this case go away, we will backfill the spaces that they leave so that we keep the whole thing as efficient as possible. We maximize the utilization on there. And the next thing we do is to say, right, we're only going to power on those physical machines that we're actually using. So now we're going to start saving in hardware terms because we're pushing the utilization up. We're going to be saving in power terms, and we're going to be saving in cooling terms. And when I find that that server is the third one up there is starting to get full, I can turn the next one on in anticipation ready, and I can have a policy rule that tells me when I should do that. Let's also talk about another aspect of this, which is utilization policy, which says how much do I want to load each of those physical servers or physical storage devices up before I move on to the next one? What's the maximum capacity I want? And you might say, for argument's sake, let's make that 70%. And in this example here, if you look at the totality of that rack, with a 70% utilization target, we're 93% of the capacity of the whole thing. We only got about 4, 5 squares at the top there that we can actually fill it up with. What happens when we're at the end of a quarter and we're desperately trying, as a company, we're desperately trying to make our number? CFO is really concerned about this. He does not want to go out and buy extra physical resource right now. With business policy, you can change the utilization target, say from 70% to 80%, as we've done there, in one easy decision, and your users probably won't notice for a short period of time that 10%, and you can backfill that space. Now, I've made more stuff available by simply changing the utilization model. I didn't have to change any of the stuff on the consumer side. Consumers don't know about this. The only thing they might see is a small degradation in performance, but as the CFO, I've determined that we have saved the company a ton of money there before the end of the quarter. Now, obviously, you can't do that ad infinitum, but another example of what policy can do for you. So taking those needs, what I want to do now is to put those three stakeholders together and the functionality we've looked at for each and say, if we do all that, can we actually get something that's greater than the sum of the parts? And let me give you an example of that. Here's utilization. And this is not our numbers, these are other people's numbers, but they show you the effect on utilization moving from non-virtualized environments to virtualized environments. And you can see that the difference there is pretty small. Yeah, it's significant, but in many cases, the actual cost of virtualization was nearly, or even in some cases more, than the costs that you saved by that increment. What you really want to get to is those orange bars where you are really starting to save serious money. But very few people get there. That's the 60–70% utilization. So let's look at how we can do that. So first of all, here's an example to say, 63 in a survey of 460 IT decision makers earlier this year, 63% of them said they hadn't saved as much as they wanted to through virtualization. Some of them hadn't saved anything at all. And if the whole point of this cloud thing is saving money, we've got to resolve that. So let's look at one way in which that might happen. Think about when you go to provision a new application. You're a consumer and you go to, you're an IT guy, you're an application guy, development guy, you need to provision a new resource. For years and years and years, you've followed the same path, which says, okay, what do I actually need right now? What do I need for expansion in the next X year, 6 months, whatever it might be? What am I going to need for expansion? If I've got to ask IT to provision this for me, how far ahead of time am I going to ask them for it? Because I know it can take anything from 3 weeks to 2 months. How long am I going to ask them in advance? Answer, a long way. And after I've done it, I'm finished with it, how long am I going to leave it hanging around before I actually tell IT that I don't need it anymore? How long is that going to be? Who knows? In many cases, there's huge amount of wastage because people do all of these things. They provision more than they need, they provision it ahead of time, and they keep it around. And they keep it around to save it for a rainy day, because it took me so damn long to get the thing, I might need it again sometime, I might use that instead. Meanwhile, it stays provisioned, and it's killing your utilization. So how can we avoid that? Let's show you a practical example. This is the Abiquo solution again, fully empowered here. This is the web example that we showed you earlier with all those various components. I go to provision that, and the system is actually popping up and saying to me there, that server or that appliance or application that you're about to deploy is going to cost you $50 a month. Are you sure you need it? This is showing forward, not showing back, not doing chargeback. It's telling your users ahead of time what this is going to cost, and it might just make them stop and think they're going to be charged for that. Do they actually need to go that far? Could they get by with less? And the key to getting by with less is these three components, these top three components. I've got complete empowerment. I can provision this whenever I want to. I know I don't have to ask an IT guy to do it. Whenever I'm ready, I can do it myself, and I can do it in seconds. And I know what it's going to cost me. The IT operations guys know that when that happens, it will be completely automatically isolated, and I will not be able to exceed the resource limits I've got. I know what resource limits I've got. The system will show me in a heartbeat what I've got and what I've got left. I know in plenty of time whether I need to ask for higher limits. And then business policy for the compliance and CFO will determine that those machines get allocated correctly every single time. You can't fail to do it because it's automatically being done for you because the rules were defined in advance. And all of that means you can do what we call just-in-time provisioning. And just-in-time provisioning is the key to saving money. Because I don't provision it till I actually need it, and I only provision what I need because I know I am in control of adjusting that however I want, whenever I want. That is the key to saving real money. So in conclusion, a successful cloud implementation must balance the needs of all stakeholders. If it's biased too much in one direction or another, it won't succeed. You have to have a balance. It is possible to do that. I believe that I've shown you examples of how you can cater for everybody's need, all stakeholders' needs, and still give people the rich capabilities that they need according to whatever their role is. And I've shown you that in balancing those, you can actually get more than the sum of the parts and start to do new things like the show forward that I showed you. Thank you very much.